aggregation of a number, and I'm talking about the marketing 5G, what Verizon and AT&T, Sprint, and T-Mobile are discussing right now. It's the next generation. It's not the true 5G that is not, the true 5G is still in the white paper stage. And like I said, the radios are going to likely to be changed to a new waveform. That waveform is not going to be spec'd out until 2020, according to the 3GPP timelines. So what I'm talking about here is the marketing 5G, the next generation, or next step in the evolution of mobile telephony. So bottom line, it's an aggregation of a number of different network functions and network features. There are several fundamental features that have to be there before the true, let's call it 4.5G, is implemented. Now, one of the primary features is network function virtualization. When you unpack what that means, it sounds like a really neat word, but let's unpack that for a minute. Network function virtualization. Instead of having a single purpose server that does one thing, like gateway or let's say firewall, you move that, you virtualize that function and move it to a higher capacity server that has that way you put a whole bunch of functions in this one box and you increase the utilization on that server box and eliminate a lot of the capital expense of these other single purpose boxes. That's all it means, is network function virtualization. We're going to virtualize these network functions and put them in a single box and use them as needed. Okay, but that's not easy. It's a very complex system, and being able to pull that function out when you need it and replace it when you don't is very, very complex. So that's another horse that we need to learn how to ride. We know it's going to buck and bronc, but we got to figure out how to set the right parameters. The engineers, network engineers today, know how it works in the lab, but they don't know how it works under load. Okay, another one is software-defined networks. Same thing. The software-defined networks basically allocates resources as needed and increases the efficiency of the network and decreases the cost of the network from a perspective of energy consumption, etc. Again, very easy to say, software-defined network, which means the network is constantly changing to accommodate the traffic parameters, but it's exceptionally difficult to manage. And then if you don't have the cybersecurity overlay on that, some bad guy could get in there and screw up the whole thing to where no one would be able to make a phone call. So these things are being very carefully designed and specified and then tested in the laboratories first and then moved to markets to where they can control the failures. It's going to fail, no doubt about it. I've been there, done that through many developments. These things fail. You just got to figure out how to recover and how to prevent failure in the future on that particular thing. Then you've got things like self-optimizing networks. That's another fundamental pillar that has to be there before these other features and functions are able to work. Now, self-optimizing, that means you've got a cell site and it's sitting there looking at all its neighbors and how the neighbors are working. It's got to have sensors to know that neighbor next door is running out of capacity, so I'm going to call in additional capacity here to offset that. Easy to say, world of difficulties there, and lots of potential failure modes. Okay, so those are the three, in my mind, the three fundamental pillars. SON, NFV, and SDN have to be there before we go on. Those are all being developed now, all being tested in the markets, but they're in their infancy. So it'll be 2020 before we really see those things come into maturity. On top of that, you've got street furniture and you've got connected car. I'm sure you don't want a bad guy tapping into your connected car and giving you the wrong signals. Proximity services. In the past, and this is really important, In public safety, you can know where a fireman is in the X and Y plane, in the horizontal plane. You can know that he's at this specific address, but if that's a 10-story building and there's a fire on the 8th floor, and that guy's on the 8th floor, you can't tell. You know he's in the building, but now what we're doing with proximity services is being able to look at the Z plane, the vertical plane, and being able to tell in real time where that fireman is. Is he in, I know where he is on the horizontal plane, but on the vertical plane, is he on the 7th floor or 9th floor or 10th floor? So that's a huge service that's going to come into place, and it's based on these other pillars. Fronthaul and backhaul, absolutely critical to the network. Low latency, high speed, low jitter, and high reliability. So bottom line, the message at the end of this session is going to be, you got to have fiber or high capacity, low latency microwave. Fiber is the best solution. DAS, small cells, all these sensor networks. I've talked in the past about CBRNE networks. That's chemical, biological, radiological, nuclear, and explosive networks that are based on vehicular mounted sensors. Have millions of these sensors running around, and you'll be able to take prescribed actions, again, based on these pillars. Carrier aggregation, VoLTE, DAS, etc. All based on small cells. I'll hurry this up because I'm bogged down a little bit. What's the current development of Release 12, which is 4G? It's a precursor to the next evolution. Bottom line, the whole thing was frozen in March of 2015. So now we're starting, the OEMs are starting to build. You'll have an 18-month cycle to develop these products and get them to market. Okay, they had some significant delays on Release 12. The objectives of Release 12, and I'm talking about 3GPP Release 12, to provide mobile operators with new options for increasing capacity, extending battery life, reducing the energy consumption, maximizing cost efficiency, and then supporting diverse applications, and enhancing the backhaul, making it efficient so that it'll fit in within the backhaul capacity. 3GPP Release 12 features. Now you're going to see these same features in Release 13, only they're enhanced. So enhanced small cells, you're going to have higher order modulation. Again, think about if you're going to have self-optimizing networks, these small cells have to be smart enough to be self-optimized, to allow themselves to be optimized. So there have to be standards for the OSS and BSS to talk to these little guys and say, hey, you're misbehaving here. Get these, I'm going to download new parameters to you. Okay, carrier aggregation. That is really cool stuff, but again, exceptionally complex, where you've got 3 frequency bands and you're pulling all those bands together and using them as a single resource. That's carrier aggregation. Now think about the etiquette. It's called access etiquette. When you enter a new band, you got to understand what it means to access the RF resources in that band, and how do you release them back when you're done, and you don't want to bump anybody off, and what happens if you're traveling 70 miles an hour down Highway 35, you know? Very complex. MIMO and massive MIMO, you're going to begin to, this will enable us to have the 3D or the vertical plane proximity services. Okay, new and enhanced services for machine-type communications and device-to-device communications. They're going to be purpose-built devices for sensor networks that will give battery life of 10 years and only use the network once a day for a small burst. So you can have these sensors out there in a network that lasts forever. Okay, let's talk about 13. It's planned for March 2016, and I say planned, that's the most recent as of last month. The RAN chair in the 3GPP said that they hope to release part of 13 in 2016. License-assisted access for LTE. and it's also called LTEU. There are lots of, we just discussed LTEU. Let me tell you, there are a lot of flavors of LTEU and access etiquette requirements that are not there yet. Enhanced carrier aggregation, we talked about that. MTC, machine type communications, going to explode. That's M2M. For those who, that's an old one. Now it's called machine type communications, where machines autonomously change their parameters to accommodate sensor networks, for example. Enhanced device to device. Instead of having to go through a cell site, a policeman doesn't want to have to go through a cell site. It may not be available. So I want to talk to that policeman that's right over here next to Berge, and so you get device to device communications. Again, complex. Elevation beamforming, that's what I talked about in the vertical plane. Indoor proximity, or indoor positioning, same thing. Single cell point to point, point to multi-point. Point to multi-point is a good technology, but what we've got is broadcast and multicast systems. So this is you're going to be able to choose, once these pillars are all set up, to do a point to multi-point system from any cell site or an aggregation of cell sites for multicast uses. Very complex again. Okay. Opportunities for infrastructure providers. What does this mean to the folks in this room, and where do we go from here? Number one is fiber everywhere. That's one of the answers. The other one is there's going to be a reduced deployment of single-purpose servers with regard to the NFV, Network Function Virtualization. Then a big area, and it's in each one of these, is third-party test and verification for proper operation. The carriers are wrestling with this new horse. They're learning how to ride it. And the OEMs, and I used to be an OEM, so I understand this, we have a lot of slideware and vaporware that we say things that can be done, but then the carriers are going to nail your shoes to the floor and say, okay, here's what when you say it does this, I want somebody else to verify it, that it does it. So I want an independent third party to verify the functionality. Okay, and that's true of all of these things. Carrier aggregation is going to be dependent on fiber backhaul, third party verification as well. So I think that's going to be a big industry. Machine type communications, I expect that to be deployed in a big way in end of year 2016. RAN expansion is going to be required, server capacity expansion, and purpose-built UEs for machine type communications that are going to last 10 years on a single battery. Okay. MIMO looks like it's going to be developed and deployed in the second half of 2016, where we're going to be able to have a lot more beamforming capabilities, and we'll go from 8 ports up to 64 ports on an antenna into a node B. Okay, again, third-party test and verification for proper operation. Then the RF modeling platforms. Currently, the RF modeling platforms rely on 2D modeling. We're going to have to move to 3D because of the interference characteristics that are going to be involved in these systems. So all of the RF modeling platforms are looking at the 3D, or the vertical plane now, the Z-plane modeling. It's going to take a lot more computer power to do that. ODAS, small cells, et cetera. I see small cells beginning to deployed in significant amounts in the second half of 2016. I see ODAS and IDAS in the first half of 17 and being really deployed because of the standards. They've got to be able to accommodate the parameter changes. Okay, I know I was standing between you and lunch. Here's the 3GP. This is the last slide, so just don't fall asleep yet. 3GPP deployment for real 5G. And you'll notice that's in 2020 is when the specifications for IMT 2020 will be released. So what we're talking about is kind of 4.5 4G or 4.75G. But the true 5G, according to 3GPP, will be released at this point in time. With that, thanks for bearing with me on that. Thank you very much.